Question 80. Base your answers to question 80 through 85 on the geologic cross-section rack. Question 80. Base your answers to question 80 through 85 on the geologic cross-section below. Rack units A through H are shown. Several rack units contain fossils. Rack unit G was formed in a zone of contact metamorphism. So here's the G. Now, you have over here the diagram. You have rack A's, rack layer A, B, C, D goes till here, E, F, G is over here. It's just like it looks like it's just a continuation. G looks like it's just a continuation of D. And here's rack layer H, sticking up in the middle. Now, question 80. Place two X's on the cross-section above to show the locations of two unconformities that formed at different times in geologic history. Well, what's the easiest way to know that two racks existed at two different times? Well, first of all, this is how the world was created, and in order for us to look at it as if it was created at different times, at least according to science, so the best way is if you see bumps in between two types of rack layers, that means that the rack layer underneath it, it got eroded, it got ruined a little bit over many years, and another rack layer formed on top of it and filled up the gaps. So that you have between C and D, that's called a disconformity. And you also have that by F. F also, it eroded the area, and E grew on top of it. So you make an X between E and F, that's a disconformity. And you also have C and D is also C and D is also disconformity, because it also happened during different times. Because first F was there, and then when F, after years of eroding, E started forming on top of it. So you make an X over here, or over here is also good. Now, between C and D also make an X. These are both called disconformities. And nonconformity is that you have igneous rock, or contact metamorphic rock. There's layers of rock above igneous or metamorphic rock, and are not changed. They do not become metamorphized in any way. So that means this C is igneous rock, right? That's what it says. On top of C you have just flat layers of rock. It was not metamorphized in any way. So you make an X over here between B and C. Make sure the X's are not right next to each other. Make sure the teacher could see it, the person following around the Regent. So between B and C, it's an igneous rock. On top of it, you have rocks that were not metamorphized in any way. They're just straight, flat. And that's called non-conformities. And so that's between B and C. Between C and D, you have that D eroded, and C filled up the areas, the gaps of erosion. So that's a disconformity. Also F eroded. That's what it looks like, it's going up and down. And E formed on top of it. That's also disconformity. So you make an X between E and F. You make an X between C and D, which are both disconformities. And put an X, you only have to do two of them. Two of these three. Put an X between B and C, and that's a nonconformity. The main thing is to know that if you see these bumps, you know that one type of rock formed, the lower rocks formed way before the ones on top of it. And if you see igneous or metamorphism rocks, and then you see on top of them flat layers that are not changed, not metamorphized in any way, So then you know that that's a nonconformity, and also, so these are, which is also a place where it was changed. It was locations of unconformities over different times of geological history. Question 81. Identify two possible geologic periods during which the sediments that formed Unit E could have been deposited. So they want to know two possible geologic periods where Section E, the sediments that formed the rack, which is these lines over here, which is E, which is between G and F, when it could have been deposited. Well, D, you see D, it says, it shows Question 81. Identify two possible geologic periods during which the sediments that formed Rack Unit E could have been deposited. Well, here's Rack E, and luckily, on top and above Rack E are different types of fossils, and the fossil that is in Rack D, which is above Rack E, means it was after Rack E. If you look in the key that they show you, it shows you that this fossil is from the Mississippian period. That means Rack E could have formed around the Mississippian period. Just that the Mississippian period, also went a little after it, because the racks of the Mississippian period went on top of the racks of E. And in F, it shows you a fossil over here, and this fossil, if you look at the key they give you, it shows that fossil is from the Devonian period. So the Rack E fell on top of the rocks in the Devonian period, but it could have been like near the end of the Devonian period, and let's say the beginning of the Mississippian period, right? Because the lower in the ground, the older it is, according to regular way of aging. The first rack goes down, another rack, sand and pieces land on top of it, and it builds up after a while. And after that period, when the next rock forms, over a long, long time, that's how they know the differences. I'm saying, according to what the Regent is telling us, that the Devonian period was this fossil, and the Mississippian period is this fossil. So Rax E was formed after the Devonian period, because this fossil, which is underneath it from F, is in the Devonian period, and before the Mississippian period, and a little bit in between it. So the question is, identify two possible geologic periods during which the sediments formed in Rack E could have been deposited. The answer is near the end of the Devonian period, but you don't say near the end, you say the Devonian period or the Mississippian period. That's the answer, right? The Devonian period, it already says period, so you don't write period. You write the Devonian or Mississippian. Now, you could have also written Mississippian was at the end of, really wasn't at the end, it was at the beginning of the Carboniferous period, because the Carboniferous period was broken into two parts. So you could have also written the Devonian period, or instead of writing Mississippian, you could have just written Carboniferous, because Carboniferous has two parts to it, and one of the parts of the period of the Carboniferous period is the Mississippian period. So you could have either answered the Devonian period. The Devonian period you have to write, but for the second, or you write Mississippian, or you could have also written the Carboniferous. So the answer is the Devonian period or the Mississippian period. And if you want, you can also write as the answer the Devonian period or the Carboniferous period. Question 83. Identify the letter of the rack unit that was formed at the same time as igneous rack unit H. So here's igneous rack unit H, and it's question 83. Identify the letter of the rack unit that was formed at the same time as igneous rack unit H. So here's igneous rack unit H, We know that igneous rock is made from lava, and if you look, we want to look something that has contact metamorphism, because metamorphism makes a change in rock, metamorphizes the rock, changes the rock because of extreme heat, like lava. So if we see these lines mean that it's contact metamorphism, you have that for D and H, for D and G. In D we already see that other things went on, so we assume that it's not D because you have a fossil in D. You also have other things that are going on, so it has to be G. So the question is, identify the letter of the rock unit that was formed at the same time as the igneous rock unit H. The answer is G. Question 84. Identify one geologic period during which igneous intrusion H could have formed. This is igneous intrusion H. Igneous rock means that lava pushed up through all these rocks and it went up till A. And so we know that anything that the lava went through, that means those rocks were there beforehand. So it was definitely after the coral period, and it was after the Devonian period, and it was after the Mississippian period. And we see over here this fossil in B. If you look at the key they give you, it says that the fossil in B was in the Cretaceous period. So after all these rock formations formed, one on top of another, the last period we know of the rocks that formed, before H pushed up through it, was the Cretaceous period. So the answer could be the Cretaceous period, but it could also be afterwards. So how many periods do we have afterwards? Well, if you look at the geological history of New York State chart that they give you, you look down the periods go upwards. So the bottom of the periods is the earliest, and as it goes up, it's closer and closer to our date. So this Cretaceous period, we said it could have happened because this is a Cretaceous period of these lines with B's, and H went through it, so this could have happened during the Cretaceous period. If you look on the geologic history in New York State charts, above the Cretaceous period, it could have happened during any of those periods also, means after the Cretaceous period. So you could have written as an answer the Cretaceous period, and above it you'll see the Paleogene period. So you could have written as an answer the Paleogene period, you would have gotten that right. You could have answered the Neogene period, you would have gotten that right also. All you have to do is answer one of them. Or you could have written the one which is closest to our date, which happened last, which is the Quaternary period. All of these, as long as these happened, as long as these things happened, the question is, it says identify one geologic period during which igneous intrusion H could have formed. It could have formed for after the rocks that it broke through. You can see that it broke through these rocks till the Cretaceous period. So it could have happened during the Cretaceous period, near the end of it, because this happened, let's say, in the beginning of the Cretaceous period, this rock formed, then H broke through it, and anything closer to our date. That means it could have happened, for example, 5,000 years ago. Could have happened. If it could happen 5,000 years ago, then it could have happened 4,000. Then it could have happened 3. It could have happened 2. It could have happened 1. Each period is on top of the other one. Just like the rock formations, when you look at them, the oldest rocks are on bottom. So through the periods, that's probably why they did it. That the lowest period is on bottom. The earliest period, like they say, I don't know how many million years ago, and as it gets closer to our date, that's where it goes up to the youngest periods. So it could have happened during the Cretaceous period, could have happened during the Paleogene period, it could have happened during the Neogene period, all you had to write is one of these answers, or you could write as an answer the Quaternary period. Of course, you write according to what you see in the geologic history of New York State chart. Question 85. Before we start question 85, I just want you to know that everything in my videos are all rights reserved. No one has any rights to make any copies of it. Even if you say that I gave you permission, you have no right to make any copies of my videos. And it's protected by all laws of motion picture, which is very, very strict. Doesn't make sense for anyone to try and make copies because it's international protected. And now we're going to do the last question. Question 85. Explain why the absolute age of the fossils shown in the cross-section cannot be determined by using radioactive carbon-14. Well, you probably learned that radioactive carbon-14, if it's in a fossil that's older than 50,000 years, you will not be able to know how old this fossil is. So I guess you'll be able to know that's more than 50,000 years old. But let's look at these fossils. This is the oldest fossil, and above it is a younger fossil, and above it you have fossil B, which is the Cretaceous period, which the end of it was, according to the way they do their science, was 65,500,000 years ago. So if carbon-14 cannot be measured after 50,000 years, so there's no way any of these fossils can be measured. So the answer to this question is these fossils are too old for carbon-14 to measure it. These fossils are too old to be measured by carbon-14. And you can continue writing because carbon-14 could only measure up to 50,000 years. And that's the end of Earth science.